Running R code in the cloud feels impossible at first. And the worst part is that your IT department probably won't be able to help you because they don't know what an R user needs. And even worse, you probably won't be able to explain what you need either. I know because I've been there. I've been trying to figure out Azure for a while and how to bring R code to Azure. But here's the good news, you don't need to go through this tedious process. Instead, I'll show you exactly what you need to do to run an R script inside of Azure Container Apps. And even better, once you've seen me do this, you know what to tell your IT department when you need something from them. So that is our plan today. Let's dive in. Alright, we're going to start with a very complicated script that we're going to run inside the Azure cloud. We're going to start with this one here. It is a script that really only has 3 lines of code. It will first tell you that it's running some calculation, then it will sleep for a while, and then it will tell you, great job, we have completed our task. And if I'm running this inside R, you see that this is exactly what it does. Here, this just serves as an example, so that you know how to bring an R script to Azure in principle. The idea here is that anything could happen in the time that R sleeps here. We're just using this as a way to practice the whole idea of bringing R code to Azure. And the way this works is by packaging up our R code into a container using Docker. Docker is a software that is made for this kind of thing. So this is why we're going to use that. If you don't have Docker installed, no worries, you'll be able to find lots of tutorials on how to do that. For now, you can just enjoy the show of how I'm using Docker to bring R code to the cloud. So the first thing that we do is that we're going to create a Docker file, which will be the recipe of the things we need to put into our package that we bring to the cloud. And this is just the file that is called Docker file. That's the typical name that we want to use here. And in this Docker file, we use a couple of predefined commands to specify what we need in the package that we're going to ship to the cloud. And one of those things is obviously our task.r file, which is the script I've created that we've just seen. So what we're going to do is to copy the task.r file into the container, into the working directory. That's what the dot is for. Just dump this into our container that we're going to ship. That's the idea here. And what we're then going to do is to run a command. And this command needs the thing to run. In this case, we want to use R. And the command for that is R script. And what we're going to run is then the task.r file. So that's what our Docker file is supposed to do. It's going to create a container that has the task.r file inside of it. And then it's going to run a R script command, which means running the task.r file. You can see this on my computer. If I were to run R script task.r, then you'd see the same calculation we have seen previously. All of this requires that the necessary packages for my script are installed inside of that container that we're going to ship to the cloud. After all, if we look at our script, we see that I'm using the CLI package here. And if the machine in the cloud that is running my code later on doesn't have that package installed, we won't be able to run it there. So this is why before we even begin copying things into our package that goes to the cloud, we're going to run our script again, but this time we're going to use it to run an install packages command. So here what we're going to do is to run our script, and it's going to execute install packages, and we want to install the CLI package. This here is just regular R code, this part. So if we were to run this in my terminal, oh, by the way, this is R, we have to go into the actual terminal. Here, let's do R script, use the E flag, and then use install packages, and there use CLI. Then it would start to install the CLI package on my computer, which is not something I want. So I'm just going to cancel this because it's already installed. Cool. So this is the first couple of things we need to run this thing in the cloud. And then what we need even before that is to make sure that the container that we are going to ship to the cloud even has R installed. And this is where we can use the from command. The from command allows us to use predefined containers that are already defined and then throw stuff on top of that. So we have kind of started doing the inverse things here. We have first done what we want to have in our container later on, but we've never started with the basis for that. And this is what we're going to fix now. What we're going to do now is to use the Docker R package, not the package, the image. That's the correct terminology here. Don't worry too much if you've never heard about this before. And then we're going to use version 4.6. And this means what this Docker file now does is that it will start with a container. Think of it as like a computer that has R installed. On this computer will first run R script. Then we'll make sure that into our computer we have brought in the test.r file that currently is on my computer. And then this whole container is assembled. And what this container will do, once it is called to actually start, it will then call R script on the test.r file. That's kind of the idea here. Again, I'm skimming over a bit of stuff here, but I think you can get the idea of this. So now that we have a Docker file, we can actually build this into an image that we can then bring to Azure. So what we're going to do is to use the Docker command. Again, you need to have Docker installed for this. And then we're going to build the container using the stuff that we have in our current directory. And we're going to tag this container. We're going to say simple task demo. This is the name of the container that I'm creating now. And the container is created by following the instruction in the Docker file. And now you see that this thing is starting to build stuff, and it finished pretty quickly because a lot of things were already cached because I have prepared the stuff earlier. Now what Docker allows you to do is to use the docker run command and then specify the name of an image, for example, the simple task demo image that we've just created. And then you see that, okay, now things are running. And so what we have done here is established a mechanism to run code anywhere. This Docker run thing simply executed the whole R thing that I have put into it on my machine. And the only thing that was necessary for that is that Docker is on my machine. So now what I can do is to bring the exact same image or container, or now let's just use these words interchangeably. I can bring these to Azure and tell Azure, hey, run this with your Docker installed thing, and then it will execute our code. So this means on Azure, we first need to have a place to put containers, or rather to put images that will later then become containers. The idea is that what we've built here with the instructions, it will create an image, and the moment you do run, like we have done here, a container is created that executes the stuff that is supposed to happen inside of it. So we first need to have a way to store the things that we have created using this docker build command. And this is what is known as a registry. And on Azure, you can have a registry for your containers, or rather for your images. It's really hard to distinguish between image and container when you're just like talking casually. So forgive me if I'm just mixing these words. Most importantly is that you get the idea of the things that we want to do here. So on Azure, what we can now do is to create a registry as a place to put in our images. And for that, there is the container registries service. Let's go for it. And you can see here that I've already created one, but just for demonstration's sake, let's create one. If you are able in your company to create such a thing, cool, you can follow along. If not, you can just watch and then tell your IT department, hey, can you please create such a registry for me so that I can use it for my R purposes later on. So as you click on create, you have a resource group. This means everything runs under an umbrella that just collects resources. You can think of it as an organizational unit that is used for billing. It's not exactly that, but in principle, it works to use this mental model for now. So let's create a registry name. Let's do YouTube videos demo. And now in this label scope, it doesn't really matter, but you could say here, put in something after the actual name that I use to make things a little bit more differentiable. But honestly, it doesn't matter too much. I'm just going with this one here. And then I'm reviewing and creating. And then I'm creating this thing. Nothing much we have to do. Really, it is just a way to create a place to put the images that we have built with Docker. Okay, so this thing was deployed. I now have this container registry. And by default, it will not have any images that we could run later on. So what we could do is to push an image. And as you click on this, it will tell you that you need to install Docker. Okay, cool. This is kind of already a given. If we want to use Docker related stuff, we need to have Docker. Then you need to have Azure CLI installed on your computer so that you can log in and then log into the container registry. You can copy this thing here and then I can run this on my terminal because I've already installed the Azure CLI, so the Azure command line interface, which means I can throw things into the terminal and Azure will know how to react. So now, as I have copy and pasted this in here, I can use the account that I have on Azure. It's just my demo account. And now you see that, okay, cool, it logged me in. And now I am both logged into Azure as well as into the container registry because I have executed both commands as instructed by Azure here. And now what we need to do is to tag our image with a name that we want to use inside of our container registry, meaning we have to start with the name of the container registry. It's this part here, followed .azure.cr.io, and then we can use the name that we want. So let's do that. Let's take this stuff. Let me throw this in here. This is the name of the registry we've just created. And then let's create this thing, simple task. Cool. And we're going to use the thing that we've just created. What was the name? It was simple task demo. Copy this. And then let's actually also call this simple task demo. So this is the Docker command that allows us to tag our image with another name. So what we can do now, throw this in here. And now all we have to do is to push this image to our new registry. And due to this new tagging, this works pretty easily by just doing docker push YouTube video demo. And then this will already autofill once I hit tab to mean this image. So now you can see that this is being pushed to my Azure Container Registry. Once this is finished, we have made it available to be used within Azure services. Cool, this was pushed now. Took a while because it was a lot of stuff. And now we can use this image inside of Azure. What we need to do is to use another service that will then grab the image from our registry that we've just created. And the service for that is called Azure Container Apps. And inside of there, we can create a container app job, which is the mode of working that we want to work with here in this video, meaning that we'll always just start a container, it will execute some code, and then it will shut itself off. That's the job part. It will just execute some code. You could also create a container that is, for example, has a shiny app inside of it that is a long running thing. But here we don't want to do that. So let's go with the job. We need once again a name for the service. Let's do YouTube demo container app. It will ask us if we want to use a specific environment. I have already created one from the preparation for this video, basically. Here we could also create a new one. Let's do YouTube demo env, and then everything else can stay as it is. No need to change anything there. Actually, it's even better not to click anything there because Azure is slow. It is just what it is. And now you see that, okay, here, this thing was created. We'll talk more about what the point of this later on. Just for now, know that we'll need to create an environment. Your IT department, if you tell them to create such a thing, if you don't have an environment yet, they will have to create one anyway, because you can't create a container app job without an environment to run in. Kind of makes sense if you think about it. So it said create validation failed. Of course, we should have clicked onto container because it is already immediately asking us, okay, what kind of container do you want to deploy? We want to, from our subscription, want to deploy the one that we've just specified, namely the registry YouTube videos demo. This is the one I've used for preparation of this video. Then we want to use the image we have just created or that we've just pushed, and we want to use the latest thing. For now, we'll just use this system assigned identity that here. Don't worry too much about it. And then we can just review and create this thing. It will tell us again that validation failed. And apparently you cannot have more than one container app environment per region. Since I already have one, which I created for preparation of this, I'll just use this one then. Let's use this one here. Next, container stays as is. Review and create. Now we can actually create all of the things that we need. Now, as you can see here, there was an error. We couldn't deploy this thing because I've made one mistake inside of creating this. So let's try this again. Let's click delete here. So here we are again, creating a new job using a container, specifying the container registry that we want to use. We're going to use the exact same images as before. And now for some reason, even though I did the exact same thing, this worked. So let's go to the resource. And there we go. There's our container app. And we do now have our container inside of this thing here. So what we can do now is to run this job. It started it. And we can see in the execution history that, okay, now this thing is running. The question now is, okay, can we see the thing that is running? And for that, there are these logs, and we need to have a look at the console logs. When you start this, you'll see exactly what I see now, nothing. It will always take a while to see the results. So you have to refresh them. There you see some logs. And here you see the logs that were created, and it's the exact output that we have used before. So congrats, we have officially run R code in the cloud. Again, the idea was to package that up inside of a container image that we then bring to our own Azure Container Registry. That is then accessed via a Azure Container Apps job, and then we can run this thing from there using the UI, and then we can see inside of the log that this thing actually ran. So that was a lot of stuff. We have seen that the user interface sometimes does weird things, sometimes telling me that I cannot do things I wanted to do, but then it works if we try again. I don't know, the user interface isn't the greatest. Now, this was a very simple example, and I do want to show you another level of this. For now, we have only run some code that doesn't interact with anything else. After all, our script is really just this sleep and show some alerts. Oh, that's not really that exciting. What becomes more exciting is when you want to interact with something else that lives on Azure. For example, if you have some blob storage that contains data that you want to use as part of your R code, as part of some processing step. If you want to do that, then you need to add a bit of extra code. By the way, if you enjoyed this kind of technical deep dive into cloud technologies using R, because I'm not entirely sure if this content is appreciated inside of the R community, because there is so little content about this. So if you want to see more of this, make sure to give me a signal with your thumbs up to let me know that this kind of content is cool and you want to see more of it. So with that said, let's get back to the video. Let's replace this stuff here. Actually, let's replace everything and run some other code. For example, we can start off with something simple again. Let's do a simple alert. I'm fetching storage containers now. And if you've seen my last video on Azure, then you'll know that this will involve the Azure Store package. So what we're going to do is to specify a storage name that we want to access. And then we need an endpoint that we access based on that storage. So we're using from the Azure Store package the blob endpoint function. This will give us that endpoint where we specify that, okay, the endpoint is really nothing but the URL using our storage name followed by .blob.core.windows.net, fancy name, but really nothing much to it. And then we need something like a password. And in the last video, I have told you about API keys. That's a way to do it, but it's not the most secure. And also, if you want to integrate with services like Azure Container Apps, you want to use tokens instead of API keys. So that's why we're going to set a token that isn't defined here yet, but I'm still throwing you the skeleton that we're going to create. And then with this endpoint, we can list all of the containers and then throw a success message that we have fetched the containers. That's great. So this begs the question, how do we get this token? Well, at first it's nothing but a variable that you define. And in this case, we can calculate this using the get Azure token function from the Azure auth package. And in there, we specify the so-called scopes and resources that we want to have. It's often something like offline access or some URL to a specific thing that we want to be able to access. In this case, we want to access storage and we want to impersonate a user. In this case, we want to impersonate me. It's always a bit tricky if you've never dealt with this before to figure out what are the scopes that you need to access here. GPT is great in talking to you to figure out what the things are that you need. That way you don't have to read the full Azure documentation. GPT can point you to the things that you need. And then you have to specify which Azure tenant you're using. In my case, it's my demo tenant that I have on Azure. And then you need to have an app ID, or also known as client ID. This is something that your IT department will need to provide for you. It is basically an application that lives inside of Azure, which you can call from your R session, so that it will ask you, hey, who are you? Can you log in? And if you can log in, then it means that you are probably a legit user. So this is why you then get a token in return. Since this is kind of a secret, I have put it into an environment variable. And if we look into my R environment template file, this is how it looks in principle. You just specify the name and set it equal to the ID of the app. Again, this is one that your IT department needs to give you. And then finally, since I'm using this type of access management or this type of list to get access to specific resources, I have to specify version 2 because this is the version 2 way of writing things. It's the more modern version basically. So now as I execute this, you see that Positron now wants to open Azure or like my web browser to check, am I actually allowed? So now I can open this and this now shows me an error saying I need something like client ID. And the reason why this probably happens is because I have not actually restarted my R session after putting in this R environment variable. So let me do that. Restarting now, trying again. And now this works. I didn't even have to open up my browser because since I have requested offline access earlier, this Azure Auth package can just renew my existing token that is saved on my computer. But if I were to take this out, then it will probably still work. Oh no, it will actually ask me to authenticate. So that's a good way to show you. It will ask me, who are you? And it will immediately from my session log me in. But what I could also do just to show you is to not open the link immediately, throw that link into a private browser, and then it will redirect me to the Azure login page. And there I'd have to log in and then everything would work. This just worked very quickly right now because obviously in my regular browser I'm already logged in, so I didn't see this sign-in message here. In any case, we do have a token now, and then we can run the other code and see that, okay, everything runs without a message. And even if I look into the containers, we see that, okay, there is this one container that I currently have inside of my blob storage. So now that you've seen the whole flow of what it means to access storage, let's think about how this is supposed to work on Azure Container Apps. Because this whole me clicking open, then logging in, and then getting a key, and then can execute some other code, this mode of working cannot possibly work because it runs on some machine that we don't have access to. We don't have any way to interact with the code that ran. We just see the logs in this log view. And this is exactly where managed identities come in. You see, as long as we're using an Azure service, we can specify that this specific instance of that service is allowed to do specific things like access a storage. And then since it's the machine running things itself, it can just grab the token from Azure's internals. So it doesn't need this interactive me hitting OK and signing in thing. And the way to then grab the token is via a different function, namely via a get managed token function. So what we actually want to do inside the container app is to call a different function. So let's do token is Azure Auth. From that package, use the get managed token function. In principle, what this does is that we can request the exact same resources with this function. And as long as it runs within a machine that lives on Azure, then we get a token with the allowed credentials or with the allowed actions. So this means we need to differentiate or let our code know when to run this thing or when to run that thing. Luckily for us, that's very easy to distinguish using environment variables. You see, Azure machines, if you look into the documentation, will tell you that they have an environment variable called identity endpoint. I on my computer don't have that. If I'm using this .getEnv and then use identity endpoint, then we see that I don't get anything back. But on Azure machines, this is where a URL would show up where this Azure machine then can get its token. So that's a nice way to distinguish, is this running on my computer or on an Azure machine. So let's create a variable that's called isAzureMachine that simply checks whether this identity endpoint environment variable is not empty. And then if this Azure machine, we can run this get managed token code. Actually, we can stick this in here. And in the other case, we can run the other code. This in here, some better formatting. And there you go. We first check, are we running on an Azure machine? If yes, then use this get managed token. And if not, we're just using our regular code that we have just seen to test our code interactively. So that way our script works fine, either if we are running on Azure or testing it locally. Unfortunately, now comes an annoying part, namely this Azure auth get managed token function is broken. I found a GitHub issue from 2023, so there isn't a good chance that this will be repaired anytime soon. But thankfully, there is already a workaround or a solution that actually implements the correct thing. And I did basically the same thing, just using header 2 instead of the original header, and that's why we need to throw in an additional function that is called get managed token, basically our own version of this get managed token function, and then we can just run this. Don't worry too much about the details here. It's really just an API request to the internal Azure endpoint that will give the machine its token. Again, ideally, you could just use this out of this Azure auth package, but it doesn't work on container apps. So here, there is this workaround. You can find the code for our own function inside the link in the description of this video. There will be a link to GitHub where I put in the function. All right, cool. So now we have our script finished. We now have to bundle this using our image again and bring that to the Azure Container Registry, and from there we can deploy a new container job. But we do have to update our Docker file here because currently we're only installing the CLI package, but for our other things to work, we also need the other packages that we're using. Namely, we'll use Azure Store, we'll use Azure Auth, and we'll use header 2. So with that, we can build the image again. So let's do Docker build. This time, let's do not simple task, but storage task demo. Let's call it that way. And now it's installing all of the packages we need. You can see that this time it takes a bit longer because this stuff isn't cached. And now that this thing is finished, we can tag it again using the container registry prefix. So let's do storage task demo. We're going to prefix it with the container registry, and then we're going to call this storage task demo as well. And then we can Docker push this thing to bring this into our cloud registry. You can see here now that this got considerably easier because only a couple of things had to be changed. Some other parts, because they are so similar to our previous Docker file, are already available inside of Azure Cloud. This was our previous container. What we could do now is to run a new container. So let's just overwrite this by deploying something else. Let's do Azure Subscription 1. Actually, we have to click it twice because the UI is not that nice. Then we click on our registry and we use the storage task demo. We select the latest. And here's where we have to be a little bit careful. We have to use the system assigned job level managed identity because this is the one that can grab a token from some identity endpoint. So we're going to have to use this one here, and then we can save this thing, hit apply to redeploy, and then we can see that this was successfully updated and we can run our container again. Let's run this thing. Let's have a look at the execution history. You see that this one is running, and we can open the console logs. And once again, we don't see anything yet because this thing probably is still starting up. Let's wait a couple of seconds. And there we see our logs now. If we sort them, we see that, okay, there is execution halted, and we already see the familiar R error. And if we look at this, we see that, okay, use multi to choose a strategy for handling vectors. And now that I see this, I kind of figured out what went wrong. You see, for this managed token, we cannot use the exact same resource specification. As I've said, this one is the version 2, the modern new version for this. But in this old identity endpoint, we can only use the old version of this. So let's also throw this out there. Also, it doesn't really make much sense to get offline access for this thing. So let's use the specification that this old standard needs, and this actually just needs the storage.azure.com URL. And here in my notes, I can see that we have a trailing / at the end of this URL. I'm not actually 100% sure that we need this, but better safe than sorry. Let's throw this in there as well, because sometimes Azure is really tedious that way, that things can go wrong because this stuff is missing. But now that we have adjusted our code, we also have to adjust our image again. Building this thing should be quick as there aren't much changes. Then tagging this thing and then pushing this thing again. And then you could think that the container app job is also updated because we specified always use latest, but unfortunately this isn't the case. We have to redeploy this container. So in a sense, it's a good thing that this mistake happened to me here, because now I can show you that we need to do things again. So we go from our logs to the container apps job thing, we go to containers and then say, okay, we need to redeploy this thing. We have to click Azure subscription twice because after the first click, everything is gone again. So then we get our registry, storage test demo, use latest, use the system assigned managed identity, and then we can save this thing, hit apply, and then it's redeploying. Now it's successfully updated. Now we can run a new job. It started one. In the execution history, we can immediately see that this new one is running. The previous one failed. We know why. So we can look into the running console, but they are not there yet. And after having refreshed this a couple of times, you see that we have logs again and we have less logs now. Remember, in the previous one, we had a whole bunch of rows here. This is already a good indicator that it might only be our error messages. But unfortunately, there is still an error because it says error token must be a string. So it is not the error that comes from header 2, but instead what we do with the token later on. And silly me forgot that this actually returns a list of things. So let's actually call this dict token. And then the thing that is supposed to actually be the token is from this dict token. We grab the token entry. Actually, it's called access token. That's the thing we need. Silly me forgot that. So that way I do have to repeat the whole process again. You could technically write a shell script that automates this thing of building, then retagging, then pushing to this, but here I didn't want to throw in extra technologies, so I'm just doing the manual work here now. And inside of this shell script, you could also then have a command that interacts with the Azure CLI to redeploy this container, because it's kind of tedious to now go back to containers and then click through the stuff here. But through the power of video editing, you don't even see the heavy lifting of this. We have successfully redeployed this and can restart our container. In our execution history, we already have 2 failed attempts. 1 succeeded. Would be great if the next one is running. That's a typical thing of making things work. You always have to try a couple of times and you always forget stuff. So let's check if this one is working now. Third one's a charm. And there you go. We have more logs now, but we also have error logs in here. But this one is actually the one I wanted to get. That's perfectly fine. Let's sort this chronologically here. So we do see requested token, fetching containers now, and then after the containers, it will say authorization permission mismatch. Really tricky word. I've said it like 4 times now. I hope my video editor cut out all of my silly mistakes here. In any case, this just tells us everything worked, but we don't have the correct permissions to actually access the data that is in the blob storage. And this is where we need to talk about the managed identity that we have used. Remember, as we have inside of the containers, we have always specified that the managed identity is supposed to be the job level system assigned identity. And if we look into this identity here, we see that this is the system assigned identity. It has the following role assignments, and currently it only has an ACR pull role. As you can guess, this is a role that allows the identity to do things related to Azure Container Registry, ACR. Namely, it is allowed to pull images. Clearly, this identity needs to be able to pull images from our registry. Otherwise, it cannot deploy a container for an image. But this also means that right now we have a missing permission to access data, and we could add to this identity. We could, on a resource group level, say, okay, it can get a specific role that allows access to the blob storage, and that is the data storage contributor. One such role will be the storage blob data contributor. That's how it's called. And now as I save this role is being assigned in addition to my pull command to actually be able within our resource group, which is also where my blob storage lives, to access data. So now as I rerun my container app, let's see if this one is succeeding now. So in the logs, still waiting for this. And now inside of our logs, I can see that there it is. We have fetched the containers, everything worked now. Hooray! But to be fair, I've actually hidden one failed attempt from you because in this video editing you haven't seen, but I went back and restarted the container because I got another failed attempt. You can see that here, but I actually didn't change anything. I just restarted the container because sometimes with these role assignments, it takes a minute or two until the role is actually granted. And that's why this thing here, this run, it failed. It didn't have permission to access the data, but I didn't change anything and just restarted things and then everything worked out. I should have just left a couple of seconds more time between assigning the role and then actually restarting the container. Finally, let's do one more advanced step that I want to throw on top of this. Because chances are you won't be able to manage the identity things here because this is usually role-based access control and this is an elevated permissions thing that you as a regular user inside of your Azure subscription won't be allowed to do. IT might be pretty sensitive about this, but what you could do is tell your IT department, hey guys, can you give me a managed identity inside of my resource group that I can reuse here, and this is something they might do. So what I've done inside of my resource group for my YouTube videos, I've created a user assigned managed identity, UAMI, and this identity has a couple of roles. Namely, it has the exact same roles that I want to use, this ACR pull and this storage blob data contributor. If you tell your IT department or whoever manages those permissions, those identities, you could tell them, give me a UAMI, a user assigned managed identity with these roles. And then inside of your container app, you could turn off the system assigned user identity and use a user assigned identity, and in there add this one that is accessible in your user group, and this is then the one that has the permissions to access stuff as part of this app. This ID has a different client ID and you need to adjust your code to make this work. What you need to do is to, inside of the get managed token function, fill the client ID with a variable that contains the client ID of this identity. And here I will just get this client ID using an environment variable that I call UAMI client ID. And if this thing is unset, then I'll simply leave this as an A and not as an empty string. That way this get managed token code always works regardless what kind of access management you want to use. But this also requires you to rebundle everything and push. So let's rebuild, let's tag, and let's push. Cool, that was easy. And now inside of my rebuilding process, I will now use my description, I will use the registry, I will use the image from before, but now I will use the user assigned managed identity, this one here. And inside of the environment variables, I do have to put in the UAMI client ID. This one is the thing that I put in manually, and in there I throw in the client ID of this identity. Your IT department will likely give it to you, or if you have viewing rights or reading rights in your resource group, at least you will be able to see this yourself inside of the client ID. So now as I save this and reapply, we are all set and can rerun this thing. And now my new job is running. And there you go, after a couple of hits on the refresh button, this call is also succeeded, but it's using a different identity now. And with that, you have a full setup of how you can run R code and even interact with some other services inside of Azure. This was a whole lot of ground to cover, but I feel like this kind of content isn't that often inside of the R world, so I felt like I should go into details here. Let me know in the comments if this was the case, if you enjoyed this. Also make sure to give this video a thumbs up if you did. And now with all of that said, I say thank you for watching and I'll see you next time.